Morning, students. Today's topic is rubber. Let us recollect what we have discussed in last class. So in last class, we discussed preparation and uses of plastic. So how many plastics preparation we have seen? Totally 6 plastics. So out of 6 plastics, 4 are prepared by addition polymerization and 2 are prepared by condensation polymerization. So polythene is prepared by addition polymerization. The next, vinyl chloride, polyvinyl chloride. It is also prepared by addition polymerization. The next, Teflon. It is also prepared by addition polymerization. Then polystyrene. It is also prepared by addition polymerization. Next, urea formaldehyde. It is prepared by condensation polymerization. And last one is phenol formaldehyde. It is prepared by condensation polymerization. The easy method to remember these preparations are, first you have to practice this ethylene. It means 2 carbons, E means double bond. So total 4 hydrogens. This is monomer for polythene. Reactant, in reactant double bond will be there. In product double bond will be broken. Ethenes are go on adding. So next one, if you see polyvinyl chloride, 1 hydrogen is removed, chlorine kept. That is vinyl chloride. Here also double bond broken and vinyl chlorides are go on adding. Just to broke the double bond and keep N. That's it. Then next, here 4 hydrogens are replaced by 4 fluorines. If you remember this name, you will get the monomer polytetrafluoroethylene. On ethylene group, 4 fluorines are there. So double bond broken and n number of polytetrafluoroethylenes are added. Then next, styrene. In ethylene group, 1 hydrogen is replaced by benzene. That is styrene or vinyl benzene. That is also undergoing addition polymerization. So break that bond and keep N. That's it. So this addition polymerization, addition polymers, polythene, PVC, Teflon, polystyrene. Very, very simple. Then this one is urea. You have to remember urea structure. Formaldehyde is common in both. And here you have to remember phenol. So 2 ureas combining with 1 formaldehyde. Here also 2 phenols are combining with 1 formaldehyde. So that water molecule is eliminated. Once you practice 2-3 times, you get the structures. Then uses. Minimum 3 uses you have to by heart. So 5 users, 4 users are there. Minimum 3 users. Total not 5 users. Minimum 3 users you study. That's enough. So in the last class we finished this topic plastic. Now today we are going to discuss rubber. So after completion of this period, you will be able to understand what is natural rubber, characteristics and structure of natural rubber, vulcanization, then characteristics of vulcanized rubber. This is very, very important. All are important here. What is natural rubber? Definition important. Structure of natural rubber important. This vulcanization process very, very important. If you know the characteristics of natural rubber, so the reverse of those are characteristics of vulcanized rubber. Okay. So we'll see first what is meant by rubber. It is a natural material obtained from latex and has property of elasticity. So how rubber you are getting? It is a natural material obtained from latex. Latex is obtained from trees. That means rubber you are getting from the trees. and it is having which property? Elasticity, whereas plastic is having plasticity. The polymers which are having plasticity property are called plastics, and the polymers which are having elasticity property are called rubber. So polymers which shows the property of elasticity are called rubbers. Okay. Then processing or preparation of natural rubber. That means how you extract. Processing is extraction, and how you are getting natural rubber. So rubber is extracted from latex present in some plants like Hevia, ficus, etc. These are some of the rubber plants, Hevia, ficus. So how you are extracting from latex? This latex is present in these plants. So latex contains nearly 35% of rubber. So whatever the latex we are getting from the trees, that latex contains how much percent rubber? 35% of rubber. Latex is diluted to 20% rubber. Diluted means we are adding water. So it is diluted to 20% rubber. Acetic acid, formic acid is added to latex to coagulate rubber particles from latex. These chemicals are called coagulants. These are added to maintain the pH around 5 to 5.7, where coagulation takes place. Rubber obtained is called raw rubber or crude rubber. Okay. So how rubber is getting? It is getting from the plants. So from the plants, which part? Stem part. So when you make cuttings or incisions in the rubber trees, you will get a milky liquid called latex. That latex contains 35% of rubber and it is diluted to 20% rubber. Then to that you have to add acetic acid, formic acid. To coagulate, coagulate means to come together, all clot, they will clot and come together. Whatever the rubber particles present in the latex, they will come together. So they will coagulate. So these chemicals will coagulate. That's why these chemicals are called coagulants. These are added to maintain the pH around 5 to 5.5. Why these are added? To maintain the pH around this much, 5 to 5.7, where coagulation takes place. That means around this pH only coagulation takes place. That's why we are adding these chemicals. That's why coagulation is taking place. So like that, all rubber particles will come together, and whatever the rubber obtaining from the latex, that is called raw rubber or crude rubber. Okay, understand? Rubber you are getting from the where? You are getting from the plants. When you make cuttings in the plants, you get a milky liquid. That milky liquid is called latex. In that latex, rubber particles are present. How much percentage is present? 25%. That will be diluted to 20%. To that, you have to add acetic acid or formic acid. Then coagulation will take place. So coagulation taking place because of these chemicals and it is maintaining pH around 5 to 5.7. That's why these are called coagulants, and coagulation takes place at the pH level. Then whatever the rubber you are getting, this is called as raw rubber or crude rubber. Then structure of natural rubber. That means whatever the rubber you are getting from the trees, that is called natural rubber. This from nature you are getting, you are not preparing artificially. From nature means from trees you are getting. So it is called natural rubber. So how will be the structure of natural rubber? So natural rubber is polymer of isoprene. That means rubber. In latex, we are saying rubber particles are present. So what are those rubber particles? Isoprene molecules. Okay. So isoprene, polymer of isoprene means polyisoprene. That means when you add coagulants, acetic acid or formic acid, whatever the isoprene molecules are present in that latex, they will come together, they will join together, and you get a polymer called as polyisoprene. So that polyisoprene is nothing but natural rubber. So isoprene units undergoes which polymerization? Addition polymerization, and use polyisoprene called natural rubber. So what is natural rubber? Polyisoprene is nothing but natural rubber. So this is the structure of isoprene. So how many carbons? 1, 2, 3, 4 carbons. On second carbon, CH3 group, that is called as methyl group. So how many double bonds? 2 double bonds. On first carbon, on last carbon, double bond. Okay, in between these two. Okay, on second carbon, CH3. Is how many carbons? 1, 2, 3, 4. Okay, how many hydrogens? 2, 3, 5, 3, 8. That means C4, C5, H8. 5 carbons, 8 hydrogens. That is the isoprene molecule or chemical name, that is IUPAC name. On second carbon, methyl group is there. 2 methyl. 4 carbons are there in the main structure. Bute, bute. 2 double bonds. Di means 2. Ene means 2 double bonds. So the structure name is 2-methyl butadiene or simply isoprene. So this isoprene molecule is undergoing addition polymerization. That is n number of isoprene molecules are undergoing addition polymerization. So here 1 double bond is there, means the double bond will break. So here 2 double bonds are there, no? This double bond will shift here, this double bond will combine with another isoprene. So double bond will be shifted to middle. So CH2, CH3, and double bond will come here, CH2. Again, one more isoprene will combine, like that, one more. So this is nothing but polyisoprene. So polyisoprene is nothing but natural rubber. So in exam, they will ask, write the structure of natural rubber. So you can write total equation, or you can write simply this one. Or write the preparation of natural rubber, they will ask. Generally, they will ask the structure of natural rubber. So any two isoprene molecules or only one isoprene, keep the brackets and keep the bonds two sides and keep n. This is the structure of natural rubber. Okay, what is natural rubber? Understood all of you? Natural rubber is polymer of isoprene. Isoprene units undergoes which polymerization? Addition polymerization, and this polyisoprene. That polyisoprene is nothing but natural rubber. The next, characteristics of natural rubber. So what are the characteristics of natural rubber? So it is having low tensile strength. Tensile means stretching ability is very less. And elasticity of rubber over a limited range of temperature 10 to 60 degrees centigrade. That means in this temperature only its elastic nature. Okay. Then high water absorption capacity. When you keep it in water, it absorbs water easily. It becomes soft at high temperature and brittle at low temperature. That means very, very high temperature, what happens? This rubber will become soft. And at very low temperature, it will become brittle. Means it will become very hard and it breaks. This is the meaning. And it undergoes deformation when stretching force is applied. That means when you stretch it, when force is applied, so it will loses its shape. Deformation means it will loses its shape. Then less resistant to chemicals like benzene, HCl, etc. So less resistant means when you put in benzene or HCl, it will spoils. Then or it degrades. Then undergoes oxidation in presence of air. So when you left in the atmosphere, you combine with oxygen and undergoes oxidation. Oxidation taking place means it is spoiling. So these are the characteristics of natural rubber. So low tensile strength, elasticity of rubber over a limited range. In this range only, it shows elastic property. High water absorption capacity, soft at high temperature, brittle at low temperature, undergoes deformation means loses its shape when stretching force is applied, and less resistant to chemicals, and undergoes oxidation in the presence of air. And next come to the vulcanization of rubber. So this is very, very, very important topic, and this is for 5 marks question. And what is vulcanization? We will see here. The process of heating of raw rubber with sulfur at 373 to 415 Kelvin to increase the strength of rubber is called vulcanization. So here raw rubber means whatever the rubber you are getting from the trees, that is natural rubber. So to that natural rubber, what we are doing, we are adding chemicals. So especially sulfur, maximum sulfur or any other chemical. Here we are saying sulfur. So sulfur is adding and we are heating at a temperature range of this 373 Kelvin to 450 Kelvin. So why we are doing this one? To increase the strength of the rubber. Generally natural rubber strength is less. So to increase that, we are adding sulfur and we are heating at this temperature so that its strength will increase. So that process is called as vulcanization. One more question. What is vulcanization? The process of heating of raw rubber with sulfur at 373 Kelvin to 415 Kelvin to increase the strength of rubber is called vulcanization. Then vulcanization is carried out to modify some properties of natural rubber like sensitive to heat, low tensile strength, high absorption of etc. So why we are doing vulcanization? To improve the properties of natural rubber. So this natural rubber is sensitive to something. So it is sensitive to heat, to increase that one. And it is having low tensile strength, to increase that one. And it is having high absorption of water, to decrease that one. So to modify some properties, we are doing vulcanization. The rate of vulcanization depends on. So the rate of vulcanization depends on three factors. So first one is how amount of sulfur added. That means how much sulfur we are adding. Then temperature, at what temperature we are doing vulcanization, and duration of vulcanization, and how much time we are doing vulcanization. So the rate of vulcanization depends upon three factors. So write the factors on which rate of vulcanization depends. One more question. So first one is amount of sulfur added. Second one is temperature. Third one is duration of vulcanization. Okay. The next, the amount of sulfur added during vulcanization is 0.15 to 32%. That means during vulcanization, in this range only sulfur is added. That means minimum is 0.15% and maximum is 32%. So during vulcanization, this range of sulfur is added. The strength of the rubber depends on amount of sulfur added. So strength will depend on what? How much sulfur is adding, whether 10%, 20%, like that. For example, a tire rubber contains 5% and vulcanite or hardest rubber contains 32% rubber. So generally tire rubber, whatever the tires will be there, that contains only 5% rubber. It is the hardest rubber. Hardest rubber means vulcanite, that is called. That contains a maximum 32% sulfur means, sorry, here 32% sulfur is this one, not rubber. 32% sulfur. Okay. So hardest rubber means 32% sulfur will be there. Generally in tire rubber, that is only 5% rubber. Okay. Then the strength of rubber increases during vulcanization due to formation of sulfur bonds and the double bonded carbon atoms between adjacent polymeric chains present in natural rubber. The following changes takes place during vulcanization. So here, strength of rubber increases during vulcanization, we are saying. So how it increases means due to formation of sulfur bonds at the double bonded carbon atom. So in natural rubber, you have double bonded carbon atom. So in between two chains, in between that double bond, sulfur bonds are forming. So due to that, its strength is increasing. Okay. What are those reactions? We will see here, and how the sulfur bonds are forming. We will see here. If you see here, this above one is the natural rubber. So here two, here one isoprene, and here two, here one isoprene. That means isoprene molecules joining and we are getting a natural rubber. This is one polymeric chain. This is one polymeric chain. Okay. This is one chain of natural rubber. This is one chain of natural rubber. So here we are adding to this natural rubber, we are adding sulfur. The temperature range here on arrow, you have to show the temperature range. So here not shown. This is also pasted from Google. Okay. So what is happening? Sulfur is going and attacking at this double bonded carbon atom so that the strength of this natural rubber is increasing. So the sulfur will go and attack here. So when attacks, this double bond will break. So whatever the structure above, same structure below, but you have to remove this double bonds and you have to keep sulfur atoms. Here one sulfur, only one sulfur, here double sulfurs are given. Here one sulfur, here one sulfur, here one sulfur, here one sulfur. So that is sulfur cross linkage. So this above one is called natural rubber. To this natural rubber, what we are doing, we are adding sulfur and we are heating at the temperature range of 373 to 473 Kelvin. Then when we are heating, these double bonds will break and the sulfur will go and attack at the double bonded carbon atoms of the two polymeric chain. This is one polymeric chain, this is one polymeric chain. In between these two, sulfur atoms with. Here two sulfurs are there, not two sulfurs, only one sulfur. So this process is called as vulcanization. So why we are doing vulcanization? To increase the strength of rubber. Natural rubber strength is less. So that we are adding sulfur so that strength is increasing. So whatever the rubber you are getting after adding sulfur, this rubber is called as vulcanized rubber. This is the structure of vulcanized rubber. This is the structure of natural rubber. Okay, so in exam they will ask explain vulcanization of rubber with equations. So you have to explain all this process and you have at last you have to write the equations. So first of all, what you have to do? First you have to do the definition of vulcanization. What is vulcanization? Process of heating of raw rubber sulfur at a temperature range of 373 to 415. Just now I told 473 something, not 473, 415 Kelvin to increase the strength of rubber. So vulcanization, why we are doing? To modify the properties of natural rubber like sensitive to heat, low tensile strength, high absorption of water. Then rate of vulcanization depends upon these three factors: amount of sulfur added, temperature, duration of vulcanization. Okay. Then amount of sulfur added is this much range, 0.15 to 32%. The strength of rubber depends upon what? Amount of sulfur added. Tire rubber contains 5% sulfur and vulcanite are hardest rubber. Vulcanite means hardest rubber means 100%. Contains 32% sulfur. The strength of rubber increases during vulcanization. How it increases means due to formation of sulfur bonds at the double bonded carbon atoms between adjacent means side by side polymeric chains present in natural rubber. This one strength how increasing means sulfur bonds are forming between these double bonded carbon atoms in between adjacent to polymeric chains. That's why strength of rubber is increasing. Okay, these are the equations and these simple equations. Here to here one isoprene, here to here one isoprene. Same structure repeating. This goes on. This bond represents, this dash represents, goes on. Isoprenes are goes on adding. So two isoprene molecules and of same structure below. Here says 3, here says. And here also same structure, double bond, broken. Sulfurs are adding. One sulfur here, not two sulfurs, here one sulfur, here one sulfur, here one sulfur, here one sulfur. So this is about vulcanization. Then next come to the properties of vulcanized rubber. So what are the properties? Whatever the characteristics of natural rubber that are in reverse, because by adding sulfur, by doing vulcanization, we are getting vulcanized rubber. So its properties will be quite opposite. Their high means here low. Their low means here high. So properties of vulcanized rubber. What is the first property? Low water absorption capacity. Okay, high tensile strength, water absorption capacity decreased, tensile strength increased, resistant to heat and chemicals. Means when we keep it in the chemicals, it will not spoil. Low wearing ability, increased strength and durability. Strength will be increased and durability means its duration will be low. Variability means low variability, low wearing ability. That means it will not tear off. Increased thermal and electrical resistance. So thermal and electrical resistance also increased. Good resilience. Ability to regain the original shape after deforming load is removed. So what I said there in natural rubber, when you apply stretching force, it will lose its shape. But here it will not lose its shape. When you apply the force, it will deform, and again when you remove the force, it again comes to its original shape. That means it will not lose its shape. That is nothing but good resilience and resistant to chemicals. Already wrote here. So these are the properties of vulcanized rubber. So up till now, natural rubber, vulcanized rubber we studied. Then synthetic rubber or elastomer, or it is also called as artificial rubber. That means not getting from the trees or not getting from doing vulcanization. It is artificially prepared. The rubber is called as synthetic rubber or elastomer. So any man-made vulcanizable rubber-like polymer which can be stretched to at least twice its length, but when the stretching force is removed, returns to original shape, are called elastomers. Very, very, very important question for 1 mark. What is an elastomer or what is synthetic rubber? They will ask. So it is a man-made vulcanizable rubber. It means by adding, totally by adding, not to natural rubber, by adding chemicals, we are preparing a rubber-like polymer. So how it will be, which can be stretched to at least twice its length. Its length is 1 meter. It will be stretched to 4 meters. Then when stretching force is removed, it returns to its original. When you apply the force, it will stretch. And when you remove the force, again it will return to original shape. That type of polymer is called as elastomer or synthetic rubber. Example for elastomer, vinyl. This is one synthetic rubber. This is a neoprene vinyl. By chemicals, we are preparing the rubber that is called elastomer. Okay, so what we have discussed in this period, what is natural rubber, characteristics and structure of natural rubber, vulcanization, characteristics of vulcanized rubber. So among this structure of natural rubber, very, very important. Vulcanization is very, very important. To know the characteristics of natural rubber, you can write the characteristics of vulcanized rubber easily. See here questions. What type of questions you will get in theory? What is natural rubber? 1 mark question. Write the characteristics and structure of natural rubber. They can ask individual, only write the structure of natural rubber for 3 marks. Write the characteristics of natural rubber for 5 marks or 3 marks. And what is vulcanization? Explain the process with necessary equations. This is for 5 marks, compulsory. Very, very, very important. And write the characteristics of vulcanized rubber. So they will ask, write the characteristics of vulcanized rubber. This is for 3 marks or 5 marks. The maximum repeated question is this vulcanization process for 5 marks. And for 1 mark, what is natural rubber? I forgot to write that 1 more question. What is elastomer? Maximum times repeated. Define elastomer. Give examples. Write natural rubber structure. What is natural rubber? So like this, they will ask. Okay, with this, we finished. Totally not rubber topic. Preparation and uses of synthetic rubbers will be there. Just rubber, natural rubber, vulcanized rubber, elastomer definition. So in the next class, we will deal with the preparation and uses of synthetic rubbers. Only 3 or 4 rubbers are there, and you have fiber. What is fiber? Definition and preparation and uses of 3 or 3 fibers will be there. So very simple topic will be left. Okay. With this, we finish half of the rubber topic. So here among this, the structure of natural rubber is very important, and this vulcanization process is very important. Okay. So what is elastomer? For one more question, this is what is elastomer or what is synthetic rubber is important. Okay, thank you, students.